All right, so you have already learned how to write a piecewise function. So we are going to, in this video, look at graphing piecewise functions. So I'm going to use some of the similar techniques that I had, including a highlighter at the boundaries. So the first thing I'm looking at here is that I have boundaries that it changes functions at x equals 1. Notice if x is less than 1, I have x plus 4. But once x equals 1 or is greater than 1, I get the value of 2. And then I have another change in function at 4. So if x is less than 4, I have the function of 2. If x is greater than or equal to 4, I have negative 2x plus 9. So I'm going to go ahead and make my boundary points at 1, and 4. So this just tells me where I'm going to change functions. Now the next thing I'm going to do is I am going to write in what each function is in each of these sections. So when x is less than 1, I have x plus 4. So I know x plus 4 goes there. When I have between 1 and 4, I have the function 2. And when I have greater than 4, so the leftmost side, or the rightmost side, I have negative 2x plus. So now the first one I am going to graph is going to be x plus 4. So I always start on my boundary line. So x plus 4, if I were to plug in that point of 1, then it would be 1 plus 4, which would be 5. So I know that on this boundary line, I am going to have the value of 1, 5. Now I always start with an open circle. And then I check, is that supposed to be open or closed? Since this is just less than, this is supposed to be open. So now from here, once I know what kind of circle, I use my slope. So I can always graph a line because this is linear. I can always graph a line using a point and then the slope. So since I have a positive 1 slope, from here I know I would go up 1, right 1. However, that is not where the function is. The function goes this way. So instead of doing that, I'm going to go down 1, left 1, down 1, left 1, and so on and so forth. Now you can also, because the y-intercept is in this section, you could have started with your y-intercept there. So now from here, I'm going to connect dots, and I have my first section of my piecewise function. Doesn't stop or anything. It goes on for all of the values where x is less than 1. So now my next section is the middle section, and that's at 2. So the function y equals 2 is just a straight line. And I know I'm going to have those boundary points there. So now on the left, I see less than or equal to, which means on the left, I'm going to fill in this circle. On the right, I see just less than, so that one's going to stay an open circle. So that is all set. So now my last function is negative 2x plus 9, and that's where x is greater than or equal to 4. So just like I plugged in that boundary point of 1, I want to see where to start this function, but this one's going to start at x equals 4. So I'm going to plug in 4 here. So negative 2 times 4 plus 9. That's going to be negative 8 plus 9. That's going to be equal to 1. So now I know I have the point 4, 1. And that would be right here. Now that point, because I have greater than or equal to, that one's going to be filled in. So now from here, I'm going to use my slope of negative 2. So that would be down 2, 1, and right 1. Notice I'm only doing this slope into the section where it applies. I would not go to the left because that is not where this function is. There is my graphed piecewise function. So notice in this section, I have x plus 4, positive slope, y-intercept of 4. In this section, I have the value of 2. And in this section, I have the negative 2x plus 9, negative slope. This one, you cannot see the y-intercept because it doesn't go over to that side. So another thing that you can do to kind of help you is to recognize these right off the bat. So sometimes I will actually do the circles in that way. So if you look at this one's less than. So I know over here I would have just an open circle. Less than or equal to, this will be filled in, open, filled in. You can see open, filled in, open, filled in. And that's all has to do with the inequality sign. So now let's look at the domain of the function. Domain is my x values. It goes all the way to the left with this arrow, and it goes all the way to the right, and everything in between is filled in. So that means I have negative infinity. Range is my y values. I see I go down on both sides, and I reach a maximum. Notice the maximum is an open circle. So it goes up to 5, but it does not actually hit 5. So you could say y is less than 5, or you could say it goes from negative infinity to 5, but with a parenthesis because it does not ever hit. Now, when we wrote the functions, we talked about continuity. If it's continuous, I would be able to trace this without picking up my pencil. Notice here, have to pick up my pencil. Again, have to pick up my pencil. It is not continuous. And there you go. There's example 3.